Have you ever stopped to think that algebra isn't just a math class, but a whole language? Seriously, it's not just a mess of numbers and letters. It's this powerful ancient code for solving puzzles and making sense of the world. So today, we're going to crack that code. We're going to use a tool called the A chart from Algebra Club to break down all the essential vocabulary you need to become totally fluent.
And this quote, it just nails it. The number one key to understanding algebra is to picture a perfectly balanced scale. Every single equation, every problem you solve is really just a puzzle where your main job is to keep both sides perfectly even. It's not some confusing maze, it's actually a beautiful, logical system.
So, where in the world did this language of balance even come from? Well, to figure that out, we've got to jump in our time machine and travel way, way back to uncover some of algebra's oldest secrets.
Okay, get this. The word algebra actually comes from the title of a book called Kitab al-Jabr, and that basically translates to the Book of Restoration and Balancing. Its author was an amazing Persian mathematician named Al-Khwarizmi, and he was working way back around 800 AD. He was literally writing the world's very first textbook for this new language.
But you know, Al-Khwarizmi wasn't just working in a vacuum. As you can see from this timeline, he was standing on the shoulders of giants, building on the work of ancient Greeks like Diophantus. And then, later on, his incredible ideas traveled all the way to Europe, where geniuses like Fibonacci picked them up and ran with them. It's a truly global story.
All right? Just like with any language, you have to learn the alphabet and the basic grammar before you can start writing poetry, right? Well, algebra is exactly the same. So let's break down the core building blocks you'll find on the A chart.
First up, let's meet the superstar of the show, the variable. Think of it as algebra's greatest mystery. It's a wild card, a placeholder for some number we don't know yet. It's that treasure chest labeled X, and our job, as code breakers, is to figure out what amazing gem is hidden inside.
Now every hero needs a sidekick, and the coefficient is the variable's loyal, trusty sidekick. If you see something like 2x, that 2 is the coefficient. It's basically telling the x how many times to show up to the party. It's the commander giving the orders.
So you have your variables and their sidekicks, the coefficients. These guys team up to form what we call terms. A term can be a simple number, a lone variable, or a variable with its coefficient. And those plus and minus signs you see, they're like the scene breaks in a movie, separating one character from the next.
Now, you can't just jump in and start solving things willy-nilly. Nope. There's a secret recipe, a strict set of rules you have to follow called the Order of Operations, or PEMDAS. Seriously, think of it like baking a cake. If you don't follow the steps in the right order, you're going to end up with a total mess. This is algebra's unbreakable rule book.
Okay, grammar basics? Check. Now let's talk about the two main kinds of sentences you can build with all these parts. This is a really, really important difference to understand.
The entire difference between an expression and an equation boils down to one simple but super important thing, the equal sign. An expression is just a mathematical phrase, kind of like a thought fragment, something like 2x plus 6. But an equation, that's a whole sentence. It makes a claim, 2x plus 6 equals 10. It's a complete statement that has to be balanced.
And as you can see right here, this rule is universal. It doesn't matter if you're dealing with simple numbers, algebraic problems with variables, or even those big, complex quadratics. The rule is always the same. No equal sign, you've got an expression. You see an equal sign, bam! It's an equation that you need to solve or prove.
All right, time to zoom in a bit. We're going to meet a really important family of expressions called polynomials. Trust me, you are going to be seeing a lot of these guys, so it's good to get to know them.
I love thinking about polynomials like a mathematical symphony. A monomial is like a soloist, just one single term. A binomial is a duet, with two terms playing together. And a trinomial is a trio, with three terms. Each one adds a new voice, a new instrument, creating more complex and beautiful math.
So how do we organize this symphony? How do we tell all these different polynomials apart? Well, we look at their degree. And the degree is just the biggest, highest exponent you can find in any of its terms. So if you see an x squared in there, that's a second-degree polynomial. Think of it like it's royal rank in the math kingdom.
And leading the whole parade is, you guessed it, the leading coefficient. When you write a polynomial the proper way, from its highest exponent down to its lowest, that very first coefficient is the leader. It's the commander leading the charge, and it actually tells you a ton about how the whole equation is going to behave.
Okay, we are so close to having all our vocabulary down.
Let's just grab a couple more key terms from our A chart. Once you have these, you'll be well on your way to becoming fluent.
What in the world is absolute value? It's way simpler than it sounds. It's just a number's distance from 0 on the number line. That's it. And since distance can't be negative, right, the absolute value is always positive. The absolute value of -5 is 5, and the absolute value of +5 is also 5.
You ever wonder how scientists talk about, like, the distance to another galaxy without using a whole page for one number? They couldn't possibly write out all those zeros. So they came up with this brilliant shortcut, scientific notation. It's an amazing tool for making the incredibly huge or the impossibly tiny totally manageable on paper.
So, wow, what a journey. We've gone from Al-Khwarizmi's ancient house of wisdom all the way to the basic grammar of algebra. All of these terms, variables, coefficients, polynomials, all of it, they're the building blocks on your A chart. So now the challenge goes to you. Can you take this chart, fill in all the blanks, and practice it over and over until you can master the entire thing in one sitting? Because that is how you truly master the language of algebra.